Module 15.4, Day 1, Perpendicular bisectors of triangles. Content standard. Students will learn to prove properties of angles for a quadrilateral inscribed in a triangle. Language objective. Students will work in groups to construct perpendicular bisectors of triangles. Proving the congruency of a triangle's perpendicular bisectors. Three or more lines are congruent if they intersect at the same point. The point of intersection is called point of congruency. We saw in the Explorer that the three perpendicular bisectors of a triangle are congruent. Now you will prove that the point of congruency is the circumcenter of a triangle. That is, the point of congruency is equidistant from the vertex to the triangle. Circumcenter theorem. The perpendicular bisector of a sides of a triangle intersect at a point that is equidistant from the vertices of a triangle. So then for perpendicular bisector, they form circumcenter. Okay, so here we're saying that the distance from A to P equal to distance from P to B and equal to distance from B to P. Right? And I want you guys to notice another is that, for example, we call that point X, called as Y, and called as Z, and the distance from A to X is equal to the distance from B to X, and A to Z is equal to C to Z, and similarly B to Y is equal to C to Y. Right? Okay, so let's go over some examples. Okay, so then example 1 through 4. Given that line P is the perpendicular bisector of segment X and Z, so this is line P and these two are congruent, and these two are also congruent. Right, so we're given that XY is 15.5, solve for ZY. So ZY is here, so it's also 15.5. Okay. Let's go on to number 2. Given that XZ is 38, so that means the distance from X to Z, this is 38, and XY is 27, and YZ is also 27. So these two are congruent, and this is a perpendicular bisector, so that means that these two are also congruent. So that means that this is half of 38. So that would be 19, and this is also 19. So the distance from Z to W is 19. Okay, move on to number 3. Given line P is the perpendicular bisector of segment X and Z, so this is line P, the perpendicular bisector, these two are congruent, that's form a right angle, and we're given that XY is 4n and YZ is 14. So that means that these two are also congruent. So we can set up the equation of 4n is equal to 14, solve for it, so n equal to 14 over 4 reduced to 7 over 2. Right, so in this class, you may leave your answer in form of a fraction, but you need to reduce it to the lowest term. Okay, let's go on to number 4. We're given that XY is equal to ZY. So these two segments are congruent, and this is a perpendicular bisector. We're given that WX is equal to 6x minus 1, and ZY is 10x plus 16. So from Z to X, my mistake, is equal to 10x plus 16. So if xw is 6x minus 1, then wz is also 6x minus 1. And we are to find the distance from w to z. So we're looking for this segment here. Right, so then we can set up our equation. So we can say 6x minus 1, send there two of them. So we can times by 2 is equal to 10x plus 16. So then using distributive property, we have 12x minus 2 equal to 10x plus 16, and combining like terms on the minus 10x plus 2 plus 2. So that's reduced to 0, that's reduced to 0, so I have 2x equal to 18, so x equal to 9. But I'm not solving for x, I'm solving for zw. So zw is 6x minus 1, so this gives me 6 times 9 minus 1. So then this gives me 54 minus 1, so then zw is 53. Right, so that's the end of our 15.4 day 1. Your assignment is in your book, number 2 and number 5 through 8, and we have a new HRW, and you are to copy down notes for 15.4 day 2.